No, 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 not that way. I want you to put one diya on the first staircase, okay? Double of that on the second staircase. Then double of the second staircase on the third staircase.
Okay, I got it. You want me to put diyas on the staircase so that every next step has twice as many as its previous step, right?
Yes, finally you got it.
But do we have enough diyas for the stairs?
Yes, Shalab, I bought diyas keeping the arrangement in mind. We have 6 steps in the staircase and I bought diyas using GP.
GP? What is GP? Is this a new credit card you got without telling me?
I'll tell you, but after you have arranged the diyas.
Good, Preet. Diyas are arranged and they look great. Now tell me about this GP card you used for buying diyas.
Okay, promise me that you will not frown.
I promise.
I used GP that Carl Gauss gave me.
Who's Carl Gauss? And why did he give his credit card to you?
No, silly. Carl Gauss was a famous German mathematician born in 1777. He's called the Prince of Mathematics. He had a gift of finding patterns in numbers. Can you believe that at the age of 10, Gauss found a shortcut for calculating the sum of natural numbers?
So this Prince of Mathematics had a credit card?
Wait, let me tell you. He found out that a sequence of term, let's say A1, A2, A3, and so on, if each successive term is obtained by multiplying the previous term by a constant, then such a sequence is called a geometric progression. In short, a GP. For example, if we take the first term as A and common ratio as R, then the terms of geometric progression can be expressed as A, A multiplied to R, A multiplied to R square, A multiplied to R cube, A multiplied to R raised to the power 4, and so on.
Oh, I get it now. You had to bring math into the arrangement of diyas as well. Nice.
I didn't, Carl Gauss did.
Who arranged the diyas outside? It is done so wrong.
Why? I did as Gurpreet asked me to.
You put one diya on the first step, right?
Yes.
Two on the second. Then why did you put 30 diyas on the sixth step? You should have put 32.
How do you know I got it wrong? Gurpreet must have bought extra. And I did as she instructed.
No, Shalab, Ananya is right. You must have arranged them wrong. There should be 32 diyas on the sixth step.
I am not wrong.
See, I told you to put 1 diya on the first step, 2 diyas on the second, 4 diyas on third, 8 diyas on fourth, 16 on the next. So, how many diyas should be there on the last step?
32.
I knew it. And that too without doing the step-by-step calculation. Gurpreet ma'am, thank you for teaching me GP yesterday.
Proud of you, Ananya. Hi, listener. Do you want to know how Ananya knows the answer? Okay. As I told Shalab, Gauss gave us this gift of sequence called geometric progression. It is sometimes also known as geometric sequence, or in short, GP. Let me tell you in detail now. In a sequence, if second term onwards, each term can be found by multiplying previous term by a common ratio other than 0, then we will call it a geometric progression. To understand this in a better way, let us assume that the first term of the GP is denoted by English alphabet A and common ratio as English alphabet R. The terms of the GP then will look like A multiplied with R, A multiplied with R square, A multiplied by R cube, and so on. In case we need to check if a given sequence is a GP or not, what do you think we should do? Yes, we will find ratio of two successive terms for the whole sequence. If the ratio of successive terms is uniformly same, we will call it a GP. Just remember that the ratio R in the GP can be calculated by dividing any term by its predecessor term. One more thing, what would happen if R is equal to 1? Obviously, the terms of the GP will stay uniformly same. Mathematically speaking, GP will look like A, 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 and what fun would that be? Therefore, while applying the concept of GP, we consider common ratio R to be either less than or more than 1. So as I was saying, the GP is AR square, AR cube, and so on. Did you observe any pattern going on in the power of R? Yes, for every next term of the GP, the power of R keeps increasing by 1. For the first term A, think of it being multiplied with R raised to the power 0. As we know, every non-zero real number raised to the power 0 is always 1. So the first term A has power 0 on R. Second term AR has power 1 on R. Third term AR square has power 2 on R. Nth term of the GP will be? I'm sure you're thinking A R raised to the power n minus 1. That's how Ananya would tell number of diyas required on each step of the staircase. Shalabh had arranged diyas as 1, 2, 4, 8, 16. Here, first term is 1, common ratio is 2. Next term in this GP should be 2 multiplied to the previous term 16, and that is 32. Let us discuss GP a bit further now. If I ask you to find out the total number of diyas I bought for the arrangement, I'm sure you will go like 1 plus, 2 plus, 4 plus, 8 plus, 16 plus, 13 plus. Carl Gauss helped me find this answer faster. He said if the first term is A and the common ratio is R, and if R is more than 1, then the sum of n number of terms of the GP is given by the formula A multiplied to the bracket R raised to the power n minus 1 bracket close and then divided by bracket R minus 1. In our case, A is 1, R is 2. Number of stairs, that is n, is 6. So, the total number of diyas required are, did you say 63? Absolutely correct answer. What about when common ratio R is less than 1? You can use the same formula or use a modified version, which is A multiplied to the bracket 1 minus R raised to the power n bracket close and then divided by bracket 1 minus R. Are you wondering where GP are around you? They are used extensively in our day-to-day life. Compound interest charged by the bank on home loan is in geometric series. Did you know how archaeologists predict the age of different artifacts? Age of artifacts in real life can be established by the amount of radioactive isotope of carbon-14 in the artifact. Carbon-14 has a very long half-lifetime. Scientists have established that each half-lifetime of 5,000 years or so, the amount of the isotope is reduced by half. Hence, these consecutive amount of carbon-14 are the terms of a decreasing GP with common ratio 1 by 2. Wait, Before we say goodbye, I have a situation at home that I need you to help me with. I had asked Ananya to do the Diwali cleaning of her room a few days back. Every day she tells me, "Don't worry, Gurpreet ma'am, I'm doing it at my own pace." With every passing day, she tells me that she's cleaned two-thirds of the room. It has been 10 days now. Do you think she has completed the tea cleaning? Do you think she will ever complete the cleaning? I'm Gurpreet Patnagar. I hope you had fun learning with me. I will see you soon on another episode of our math podcast.